Okay. So, is it true? You want to know about magnitude, huh? I heard this word. What's that magnitude? I want to know about magnitude. Oh, I got you. Welcome to Fizz Teach Video Magnitude Scientific Notation Order of Magnitude. So what's that magnitude? Well, you've been doing magnitudes. You just may not have known it. You see, you go to math class. Math class, they say, hey, what's the value? How much? How much is the answer? If you come to science class, we don't say what's the value. You say what's the magnitude. Basically the same thing. So in science class, I say what's the magnitude. You're just going to give me an answer like you did in math class when your teacher asked you what's the value. You see, this all really comes from the fact that we work out a little differently. See, your math teachers, when they work out, they go get their supplements at value drugs. Reasonable place, good prices, good product. See, your science teachers is a place around back. It's not called value drugs. It's called magnitude drugs. You really want to get beefed up on this stuff, you want to get your business at magnitude drugs. So magnitude is just how much in a science class. That's all. Now we have this third phrase here, order of magnitude. Oh my goodness. Order of magnitude actually doesn't quite mean what it sounds like. Order of magnitude still has magnitude, which is how much, but the order of means approximately. So approximately how much. This one is really an estimate. Now, though again, you need not get too much test anxiety about this sort of business. It's fairly light in our course. It is quite useful in many real-life contexts to know approximately how much. You can make estimates of all sorts of crazy scenarios and actually get pretty decent answers. We'll do some of that when we do our Fermi problems. Okay, so let's go check this out. On the next page, you will see example 9, orders of magnitude. Write each order of magnitude. Now, if you remember, magnitude is how much. Order of is just approximately how much. Now, here's how you do it. This number, 10 to the minus third, that's just shorthand for 0.001. Let's not worry about that just yet, but 10 to the minus third is just a number whose order of magnitude is approximately 1,000th. How do we record that? We just write -3. You say, well, wait a minute, what? Look, keep it simple. You want the order of magnitude? Look at the power and write it. The -3 doesn't mean -3. It means 10 to the minus 3. And the shorthand for writing it is just write the power. Oh, so that's easy. 10 to the minus first, that's 0.1. Oh, the order of magnitude is just -1. 10 to the 0 is just 0. 10 to the 1 is just 1. 10 to the 3 is just 3. 10 to the 6 is just 6. That's easy. By the way, just in case, don't get fancy with the negative exponent. Do I move the decimal to the left or the right? We'll talk about that in a minute. Oh, the positive, which way to... If it's negative exponent, it's a small number. You got to have a decimal, some zeros, and the number. If it's a positive exponent, it's a big number. Okay, let's keep going with that. This note, make friends with the EE button. This is a fantastic button on your calculator. Some of you won't believe me at first. Make use of that EE button. That EE button will change some of your mathematical life when you're doing problems in here. In fact, I'll put a link at the end of this. You should go check out the video on my channel. Video is called none other than EE button. It's got 41 views right now. It's close. I feel like it's just on the edge. It might start trending. Two likes, 0 dislikes. That's a good ratio at least. Okay, let's go over here. Place the following numbers in increasing order. Now this connects to the note that we just wrote up here. No fancy rules. 10 to the minus 5. Oh, negative exponent, that's a small number. 10 to the minus 2, small number. 10 to the minus 6, small number. Minus 6, smaller than minus 5. So this actually is the smallest. So the minimum, we can put them in order right here. Number 1, that's the smallest. Increasing order, by the way, you'll see that a lot in this course. That means go from small to big. If you put a class in increasing height order, you got the short in the front, the tall in the back. Okay, the next smallest would be 10 to the minus 5th. then 10 to the minus second, then 10 to the 0, then 10 to the positive 6th, among this set of numbers. All right, fine. These are baby steps so far. Now let's start to do this real deal scenario. Here are magnitudes listed. On question 15, magnitude. So this magnitude is 0.000001. 2, 0000000. You see what we got written over here. If you were to put this in scientific notation, you're used to making the loops. The decimal, if we put this really in standard scientific notation. Standard scientific, we want the decimal, it currently is right here. We want it over here, immediately to the right of the first non-zero. How do we get there? Well, let's just count. 1, 2, 3, 4, 5, 6. It's a 1 times 10. There has to be a 6 up there. Is it a positive or a negative 6? Well, again, go back to that basic rule. Don't get fancy about, oh, I moved to the right and moved to the left. Is it a big or a small number? 0.000001, that's a small number. It gets a negative. There it is. 1 times 10 to the negative 6, aka 1 millionth. Done. Let's go over to the next one. If you don't see a decimal written, just pretend there's a decimal, a little phantom decimal here at the end of the number, all the way to the right. We want it immediately to the right of the first non-zero. So the very first non-zero is at 2, and we got to move over. 1, 2, 3, 4, 5, 6. Okay, this is now 2 times 10 to the, is it positive or negative 6? We move 6 places. That's 2 million. That's a big number. It's a positive 6. Done. Next one. All right, we want to move our decimal here, immediately to the right of the first non-zero. That moves 1, 2, 3 spots. So we have 4.321 times 10 to the, we move 3 spots. This was a small number. We're going to put a negative there. 750. Okay, immediately to the right, boom, boom, 1, 2. So 7.50 times 10 to the, move 2 spots, it's a big number, positive 2. And then finally, 1, 2, 3, 4, 5. We want that decimal right there. And we have 4.0 times 10 to the, we move 5 spots, it's a small number, make it a negative. Now before we continue, there's some sig fig business going on up here. You want to maintain your sig figs. The original number, the original magnitude is what gives you the sig figs. So let's check out, what did we do over here? Is this fair? These were all lead zeros, so no, 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 no. None of those were significant. This was one sig fig, so we're good down here. Trail zeros, if you remember, were our exception. That was that funny scenario we weren't sure. This one could be any number of sig figs, ranging from 1 up to basically 6. If it were 7, we'd put a decimal at the end. So you can have anything in there. This one is really a little tough on the sig figs. You need more information. This one, lead zeros are out. 1, 2, 3, 4. 4 sig figs. 1, 2, 3, 4. We're good. This one, lead zeros are out. All these, there's a decimal there clearly. 1, 2, 3 sig figs. 1, 2, 3 sig figs. We're good. Here we have lead zeros. They're all out. And then 1, 2 sig figs. 1, 2 sig figs. We're good. Okay. No test anxiety on that. But you can do it, so you might as well. It's the right way to do it. Now let's get to what we're working on today, which is the order of magnitude. Order of magnitude is just approximately how much. I'm going to warn you. You want to be in standard scientific notation before you start doing order of magnitude. What do I mean by that? Well, 2 times 10 to the 6th is the same thing as 20 times 10 to the 5th. Wait a minute, those have different powers. How am I going to interpret this? It makes the game a little more complicated. In fact, this is the same thing as 200 times 10 to the 4th. And so now you start to say, oh, wait a minute. The simplest and also accurate way to do this is just put it in standard scientific. You won't have to worry about it. Okay, so this one already, we have them all in standard. Now you just look at the power. Power here, negative 6. Good. Order of magnitude, negative 6. Look at the power. 6. Order of magnitude, 6. Now here's the thing. Unlike what we did up here in example 9, there are coefficients, there are numbers in front of your times 10 to those. Do those numbers mean anything? I mean, 1 times 10 to the minus 6 certainly is not the same thing as 9 times 10 to the minus 6. Heck, 9 is almost the same thing as 10 to the minus 5th. These are much closer to each other than these two are. So there must be a rounding rule. And just like there's a rounding rule when you use a linear scale. So here it is. You're going, here's your linear scale. You have a 0, a 1, a 2. Ooh, that's a funny 2. Losing some orientation. Okay, a 2. Now, how exactly would you round in this scenario? Well, that's not so hard to do. Basically, if you are midway up the interval, we round up. So here's like 0.3, here's 0.7. And what's the cutoff? We know if it's 0.3, you would round down to the 0. If it's 0.7, you might round up to the 1. Where is it? What's the cutoff point? Right in the middle, that's at 0.5, halfway up the interval. So let's say 8.5, you could round that to 9 if it were a 1 sig fig problem. 8.3, you would round to 8. And of course, anything bigger than 8.5, like 8.7, you would also round to 9. Okay, so our midpoint was at halfway through. When you use a log scale, this is a base 10 scale, the rounding rule is different. This is all this note right here. The rounding rule is different because the midpoint on the interval is different. Let's say you have 10 to the 0. In the next spot over, 10 to the 1, 10 to the 2, 10 to the 3. You say, okay. Well, so right here is the midpoint, the midpoint, the midpoint. Well, isn't that just 5 times 10 to the 0? Wouldn't this spot be 5 times 10 to the 0? And the answer is no, it would not. This is a log scale. 10 to the 0 is equal to 1. 10 to the 1 is equal to 10. 10 to the 2 is equal to 100. 10 to the 3 is equal to 1,000. So this is not actually true. If you notice, with each move up on the interval, it's actually covering more and more numbers. In fact, within the interval, as you move along to the right here, it's covering more and more. That midline is not 5. That midline is actually the square root of 10. Ugh, not something you wanted to worry about. The midline is actually the square root of 10, which here is about pi. It's 3.16. That's our rounding point. So, okay, I know this feels like a little extra, but listen, you want to pursue perfection, you got to know the details. Here it is. When the coefficient is greater than or equal to 3.16, aka the square root of 10, you then will round up the power for the order of magnitude. Now in this case, 1 is less than 3.16. You don't need to round anything. 2 is less than 3.16. Leave it alone. But what about this next one here? If you just took the power, it's negative 3. But if you look at the coefficient, 4.321. Oh, that's bigger than 3.16. And that actually makes our negative 3 1 power bigger. What's 1 power bigger than negative 3? It's negative 2. Look at the next one. This is 10 to the 2. So the order of magnitude, you say, oh, it's just 2. But you look at the coefficient. The coefficient is bigger than 3.16. So this 2 gets rounded up to a 3. And let's look at the last one. Negative 5. So you would say this is approximate power negative 5. But then you look at the coefficient, it's 4, which is greater than 3.16. Your negative 5 goes up a power to negative 4. That's how order of magnitude works. Now, should you have test anxiety about this? At most, you get one question about it. So I'm not going to tell you it never shows up. It's rare, but it can show up. That's why we're learning it. And we will set you up with the ability to achieve perfection. So, you want it? Here it is. Over here we got this other note. Check this out for a moment. You may have noticed the spacing up here. That in between the zeros and the 001, in between the 2 and the 3 zeros and the 3 zeros, there are gaps. You see these gaps written in here. Instead of commas, typically you do commas, but here there are gaps. Those gaps are actually by design. The standard method for writing out numbers with lots of digits is to write them in groups of 3, then with a little space. Sometimes, depends what country you're working with, a decimal is a comma and a comma is a decimal. The symbol actually means something different. They reverse. To avoid all that, you have one, either comma or decimal, to represent what we have as a decimal, and the groups of 3s. You don't have to write them this way. You can write them how you normally do. You can put decimals and commas. That's fine. But I will typically write them this way, and you'll sometimes see them on tests, including the Regents exam, written this way. It actually makes it easier when you get used to it, seeing those groups of 3s, to know how big or how small a number you have. Okay, in case you see it on a question, don't get nervous. This full 2 million is part of it. That full 0.004321, that's all part of it. All right, let's get down to question 16. Sorry, we got some slop in the way, but you'll be all right. Turn these into standard notation. So now we're trying to get rid of the scientific. Okay. We're going to skip number 1. We're going to come back to that one. The others are actually a little easy. Let's go to number 2. This is 2.5. We'll rewrite it over here. 2.5. The instruction is to move the decimal 4 places. If you go back to the note at the top of the page, you don't need, oh, go to the left, go to the right. Get that out of your mind. Big and small. You won't forget it. 10 to the 4th, that's a positive. Make it bigger. Move it how many spots bigger? 1, 2, 3, 4. The new decimal will be here. That's out. You actually don't need a decimal over there, but 1, 2, 3, fill the loops. And the answer is 25,000. If you look originally, this number is 2 sig figs, so your answer should be 2 sig figs. You don't need a decimal on the end of it. Next one, 0.5 times 10 to the 1. That's an instruction to move the decimal 1 place. It's a positive, make it 1 bigger. Now it becomes, plain old, 5, still 1 sig fig. 8.25 times 10 to the minus 6. 8.25. The instruction says move it 6 spots. Which way? Forget left and right. It's negative. That means it should be smaller. So go to the smaller side. 1, 2, 3, 4, 5, 6. You will need a decimal here. 1, 2, 3, 4, 5. Fill the hole. Put a lead 0 out there. Your answer is 0.123. 1, 2, 3, 2, 5. There it is. Written out nice, neat. Finally, 1.11 times 10 to the 3rd. The instruction is to move it 3 spots. Positive 3 means bigger. 1, 2, 3. Fill in a 0. Your answer is 1,110. Actually, if I'm going to be true to the spacing, 1,110. There it goes. Notice we had 1, 2, 3 sig figs, so 1, 2, 3 sig figs is good down here as well. Change that color. It looks like exclamation points. Now, the one we didn't do is this one. 10 to the minus 1. Some of you are going to say the answer is 1. But you see, you'd be mistaken. If there is no coefficient, in front of your 10 to the, put a 1 in front of it. This is identical to 1 point times 10 to the minus 1. And now, do the same exact thing. All right, take the 1 point. We take the 1 point and move it 1 spot. 1 point, 1 spot, bigger or smaller? Smaller. Boom, there it is. Answer, 0.1. So put the 1 point in front of it in case you're not sure. This is 0.1. 10 to the minus 1 is 0.1. It's not 1. Finally, just a sig fig review. How many sig figs from question 15 and 16? Well, 16 is right in front of us. Let's do it. This one here, that's just 1. You see, you look back at the original. That had 2 sig figs, which we were saying before. Choice 3 had 1 sig fig. Part 4 had 3 sig figs. And part 5 had 3 sig figs. The original notation will give you the right answer. Back on question 15, let's count those up again. Where is it? Here it is. We go from the original. We counted them before, but it was 1. Anywhere from 1 to technically 7, but more likely 6, 4, 3, and 2, which we did count up before. So that was 1 Anywhere from 1 to technically 7, but more likely 1 to 6. Again, don't worry much about this one. And then what did we have? Was it 4, 3, and 2? That's nice and easy. All right, there it go. More fun than you can shake a stick at. Hopefully you learn a little something. Adios.